So for every problem you do, like you would start off. Maybe I'll do number 6 as an example right now. No, not number 6. Save that one. I'll do number 4. Could someone read it? This is number 4. Shh. Okay, whoa. Just read it slow. I'm gonna stop you. What is the what? Okay, whoa. I'm gonna write a list of givens. You guys with me? And we don't know the acceleration. It says, what is the acceleration? So I'm going to immediately do that. A equals question mark. Are you guys with me? Now, start over. Oh, whoa, stop. 300,000. What are the units? Okay, I know kilograms measures what? Mass? Good. There, I got another given. Start over. Read it again. Thank you. But this is what you do for real. This is how you do it.
What is the acceleration of a 300,000 kg jumbo jet just before takeoff?
Thrust. What's thrust? Force. Okay, so that's force. I believe that's the air pushing on the jet to make it go, right? What's the thrust? It's probably some big old number. All right, I remember this. I think I either made these numbers up or I got them from some problem in a book somewhere, right? And so I think we made an attempt to make the numbers realistic. So these are really forces acting on a jet, all right? And I'm going to do an elaborate diagram. I'm going to do like super elaborate diagram. There's my jet taking off. Are you guys with me? Oh my God, it looks like a box. I'm so sorry. Okay. So now that I got my jet drawn nicely, let me draw, I don't know, a force diagram. What y'all think? Oh wait, no. Is the jet gonna have an acceleration? So why don't I just draw a motion map to show the jet taking off? How long did that take? Like 10 seconds? Most people aren't doing that, and I think it would help a lot. Are you guys cool? And which way is the acceleration in my picture? Okay. This is super valuable because now I know my acceleration is to the right. And if I understand Newton's second law, my net force better be to the right. It makes things easy, folks. So now I'm going to select my system. I'm going to draw a force diagram. What forces are acting? There's weight. What else? Normal. What else? Okay, I'm going to ignore air resistance only because the problem's not solvable with including air resistance because I don't even know what it is. You guys with me?
Yes.
I agree that it would be a factor once the jet starts to take off. I agree it's a problem with this problem, right? You guys cool? Now, which way would be the force due to the air pushing on the jet to make it go? To the right? All right. Are you guys good?
Yeah.
So force, air. All right. Now what do? Notice I'm all organized here. I got my givens. I got my diagram. I got my force diagram. I'm trying to keep things organized. Okay, so we're adding vectors. Why are we doing that? Because Newton's second law requires us to find the net force, right?
Yeah.
So let's add the vectors head to tail. Normal, force due to air, and weight. And I'll label them. Normal, force due to air, and can I write, this is actually part of my givens list. You might not have realized it. Yeah, isn't weight equal to mg, and I know my mass? And isn't g 10 newtons per kilogram? Or g could be 10 meters per second squared. Those are equivalent. Are you guys cool? So I actually know the weight is going to be mg. So I'll label that mg. Are you guys good? Now, which way is my net force going to be? I have a couple ways of checking. First off, which way is my acceleration? And if Newton's second law is true, there's Newton's second law, A better be in the same direction as my net force, right? Otherwise, something's wrong. Okay, so Stephen, how you doing? He didn't get much sleep. So my net force, we've decided, has to be to the right because that matches my acceleration. The other thing you can do to check is if I draw my net force to the left incorrectly, do you guys notice it would be head to tail like the other vectors? Your net force is not head to tail with the vectors you're adding. Your net force is the vector you get when you add the forces. So it shouldn't be head to tail with the rest of them. Does that make sense? The net force vector needs to be tail to tail, start here, and end at the head of the last vector. So this has to be my net force. So I have two ways to check that I draw my net force vector correctly. Brian, how's the basketball game going? Now, what should I call that net force vector?
Force.
I could call it net force, but I'd prefer if you guys use Newton's second law and replace net force with ma. Does that help? And now, in this problem, do you folks notice that I'm trying to find a? You guys see that? And look, I have ma there, and I have f air, and I have m. I actually have m, and I have f air. And can you tell me what ma is got to be equal to? Isn't okay, but look at your vector sum diagram. What two vectors have to be the same length there? So I know that normal force has to equal mg, and I also know that ma has to equal f air. You guys following me?
Yeah.
That's from my vector sum diagram. These two have to equal each other as well. Yeah? So if I solve for a, what do I get, please? Don't put any numbers in. What do I get? Solve for a? I don't hear you guys. Divide both sides by m, what you get? There you go. F air over m. Now, if you stopped here, I would still be quite pleased with your work. In fact, on a test, if you solve things generally so beautifully and you show all your logic, I probably wouldn't mark anything wrong. If I did, it would be like not even a point. I'd feel bad taking off a point. Put it that way. Even if you put the numbers in, calculate them wrong. What's F air? This last step is not that important, but what's F air? How much force? I don't hear you. How much force is due to air thrust on the plane? 120,000? And how much mass again? I suppose if you divide these numbers, you'll get the exact acceleration. And I got a shortcut here. I can cross out those. I can cross out that one. What's 12 over 30? Isn't that 6/15? Isn't that 2/5? So that's 2/5 meters per second squared. I'm done. You guys cool? I just found the acceleration of that jet, and I think that's what we wanted. So you guys getting an idea how you can structure your work and make it easier for yourself? Hopefully that helps. Anyway, I recorded that so you can look at that later if you want. Why don't you guys try, that was 4, try 5 and 6 at every island. So half the island does 5, half does 6. Is it about that? Okay, we'll talk in a minute.